Welcome back to the second video. We'll be talking about how blockchain works in this video. So, how it works is, in theory, what happens is blockchain is a group of blocks that are connected together. So that's why it's called blockchain. So there's a chain chaining the blocks together. The blocks are a a combination of transactions or group of transactions that has been performed by someone. So this group of transactions are packaged, bundled into a group called a block, and then to add the block to the network or to the chain, the block is given a hash. It keeps track of a hash. So the hash is like maybe a pin, a password. Then it also keeps track of the previous block's hash. So what happens here is, for someone, maybe a hacker, to be able to break the chain, he has to calculate the hash for the previous block, calculate the hash for the current block, and then start fitting in these hashes in their different position to connect them. So you start seeing why blockchain is really secured. Before you someone would really do this, it would really take a long time, and it might be frustrating, and no one really liked being frustrated, and so they might actually give up. So that's what happens. So how it starts is, every blockchain starts with what we call a genesis block. The genesis block does nothing really. It might not even have any transaction inside, but it's just a basis for the blockchain to get started. So after the genesis block, every other transaction or blocks of transaction is now built on that genesis block, which is like maybe a dummy block that don't really do anything. As users continue to join the network, the chain keeps growing, and then they all have access to their transaction, and they're able to see what's going on in the network. Basically, that's how every blockchain works. Every blockchain you can think of, Bitcoin, Ethereum, and the rest of them. So this process that we use to add this block is called mining. So you could hear people talk about mining of blocks, mining of crypto, stuff like that. So basically, they are adding a set of transaction into the chain or the network. Then the process of calculating the hash and adding the hash to every block is called proof of work. Basically, you're trying to make sure that this thing is correct. Most blockchain uses what we call the SHA-256 hash. SHA-256 hash. Let me share my screen so that you could see what's going on. Where is that? Okay, this is it. This was where we stopped. Okay. All right. So SHA-256 is SHA-256. We'll just Google it. Right. So the first search here, SHA-256 online, click it to open. So what it does is, each time you enter a string, say G, it generates this long string. It's a 64 character hash. No matter how long the string you put in here, it will always generate a 64 character hash like this. Now let's say we put man. Look at the hash it produces, man. Now if you see what ends it ends with a 00B03. it starts with A48B67. Now, the thing with SHA-256 hash is it gives you the same calculation of the same string anytime you impute that string again. So let's say we check for woman. You notice that the string changes. But when we put back man there, it gives us exactly the same kind of hash. It's not just a random hash. It's very different from many hash we have already existing. So you can see why it is highly reliable. Now, how does blockchain use this hash? It generates the same hash over and over again. But the thing with blockchain is, in blockchain, they try to ensure that the security is high. So they specify how maybe the first 5 character, the first 3 character should look like. So the blockchain could say, I want the first 5 or maybe first 3 characters to be a set of zeros. So this means that we need to regenerate this hash over and over and over again. So if that is the case, and SHA-256 hash do not change their calculation, so how then do we get these things that are specified by blockchain? So what happens is, in blockchain, we have what we call a nonce. It is spelled Nonce, a nonce. So what this is basically is a number that will be added to any string you want to get the hash for. So say for example, we have man. If we add 1 here, this 1 that is added here is a nonce. If you add 103, the 103 here is a nonce because it's not actually part of what you want to hash. It is just something that's added in order to get a particular result. So what happens is, in calculating or generating the blockchain's hash, what you do is you keep adding a number. So you could add 1 and recalculate the hash. 1 didn't give us the result. We remove 1 and add 2. That still didn't give us the result we're looking for. You remove 2 and add 3. So you keep doing this, adding different set of numbers until you get a particular pattern that you're looking for in the hash. For example, this one now gives us a set of 777 at the beginning, but that's not what we're looking for. We're looking for a set of zeros. And so that's basically how it works. We'll do all this in practice in a bit. So we'll move over to VS Code. VS Code, yeah. All right. I've not done anything fancy here. I just created a new folder called blockchain intro, and then we'll start from here to do whatever I want to do. We'll add a few files. The first file I want to add is the package.json file. To add that, let's open our terminal. So to open our terminal, you go to file and where is that? All right. So you could just use a shortcut. The shortcut should work. That should be Control Shift. Yeah, Control Shift. Then the back tips. All right. So what we want to do here is to add the package.json file and the details in it. Basically, what we need to do is to initialize this project. So you just use the command npm init for short for initialization, and then it gives you a bunch of message here, but it doesn't really matter. You just hit enter until the file is created. So that's what I'm doing. I keep hitting enter. Basically, we are saying we are accepting everything they are giving us, and yes, we accept. Now the file has been created, package.json. Yeah, so this will help us to install packages during the course of this tutorial. Well, it's just one package that will be installing, and that will be the SHA-256 hash. So let's install that. npm install SHA-256. That's the package name. That should take a moment and we'll be good. While that is it's done. While that is happening, well, we wanted to add a new file. The file will be named blockchain.js. So we'll be writing all our code in this file, the whole thing we want to do. All right, then we need a second file. The second file will be for testing whatsoever we create, and that will be, let's do tests.js. Yeah. All right, we will just import the SHA-256 on top of here like this. Const SHA-256 equal to require SHA-256. Yeah, that's correct. All right, so how does this SHA-256 hash work? Let's demonstrate that a bit. Basically, what happens is you just call the function like this, SHA. It's a method, and you just pass in the string you want to pass in, like man. That's it. You could just add dot to string here, just to be sure. Sorry. All right, then well, that's it. Let's save it, and then let's do node block. Okay, blockchain. Oh, sorry, we are supposed to log this to the console.log. Node blockchain. Now, do you see? This is the same string we got when we did it on the web. We are getting it also here in the in our project here in JavaScript. So it never changes. It follows the same pattern anywhere, anytime. For us to now get our desired kind of hash, we need to loop over this thing and call it a couple of times. I mean, over this line of code. So what do we do? Let's start by creating a hash and setting it to empty string. We'll announce also, and we set it to 0. Then what we'll do is we'll say while we'll do a loop, and the condition is as long as the first 3 string isn't equal to 3 zeros, it should keep going until it gets to that point where it has gotten 3 zeros, then it could stop. So for us to do that, we could say hash. So we are saying this hash, if this hash dot substring, that is, we're saying from 0 to 3 is not equal to a string of zeros, don't stop. So inside here, what we will do is, as long as we don't have the hash we're looking for, we keep incrementing the nonce. We keep incrementing it. So we increment, that's the first thing we're supposed to do. Then we'll call on this function here. But the difference now is we are adding the nonce like this. So each time we try to loop through, we add the nonce, and we keep track of the nonce, because that's how we recalculate the hash in the future. Like, well, that is if we are creating our own blockchain. All right. And then when we are done, we just log to the console. What we are logging to the console, two things. First of all, we are logging, let's log the nonce first, so that we'll see how long it took it to get what we are looking for. Nonce. All right. Then let's put a space between. Yep. All right. Then we'll log the hash. Let's see how that goes. So Control K to clear, and then we do this again. That's taking a while. All right. I'm not sure why. Oh. Made a mistake here. I'm supposed to be keeping track of the hash here. So hash should be equal to this. No wonder we're not getting any results. Okay. So this should be fine now. Let's do this again. Hopefully that should work. Beautiful. Now, this is it. It had to go 5,707 times before we got this desired hash. I hope that makes sense. So it means that before we got this hash, we had to add man to 5,707 integer. And so when we want to recalculate this hash for this man, while we know the hash we are looking out for is for the man, we just add this in order to know that, hey, we're looking for the hash for the man. But for us to have been able to get this desired hash, we had to add 5,707. So when you think about this, for a hacker to be able to break this kind of hash, it will really take him a very long time, or maybe even impossible, because this person might need to calculate this for up to 5,707 times. So this starts giving you an idea of how secured or how seriously blockchain takes its security. And that is it. I hope that is clear. We'll now move into building a form of blockchain using JavaScript. So we'll clear all this. All right. We'll also clear our terminal and we'll bring this down. So I told you we'll be using the OOP, object oriented programming language. All right. So yeah, let me close that off. Object oriented programming language starts with a class, basically. Well, some use prototype, but class is the most common and most acceptable. So we do a class and then we name the class blockchain. Yeah, all right, blockchain, and open and close curly braces. Everything will happen in between these curly braces. Yep. The first thing we do in a class is to define a constructor. Now, a constructor is where the very first code runs. That is also the best place to define your variables. So let's do that. Let's define a constructor. Beautiful. We'll clear this. We don't need this. For this program, we need two variables. One of them is chain, which is going to be an array of blocks, and the second one, pending transaction. It's also going to be an array, but this time around an array of transaction. But the thing is, when declaring variables in blockchain, sorry, not in blockchain, in a class, if I mix that up, we need this keyword before the variable, like this dot chain and this the pending transactions. All right, so like we said, the chain will keep track of all the blocks that have been added to this blockchain, while the pending transaction will keep track of all transaction that has not been added to a block. So what that means is, as soon as a transaction has been assigned a block and added to the chain, we clear everything in the pending transaction so we don't have duplicate of transactions. The first thing that we're supposed to do in the chain is to add the first block, known as the genesis block. So for us to do that, we could hard code this into this place and just add details of the block, but I want to make the code clean. So we'll create a function known as create genesis hash. Sorry, not hash, block. Create genesis block. All right. Now something you notice is in JavaScript, when you are creating a function inside a class, you don't have to start spelling out function in the front, saying this is a function, stuff like that. All right, so what do we want to do in the genesis block? We just want to add a dummy block, kind of. So since we are adding the dummy block, we don't need to start creating a special hash or anything. We just need to put the details of the block that we want to add. We just put the keys and put the value. What our block is supposed to have, first thing, is supposed to have an index. Second, it's supposed to have a timestamp, basically when it was created, something like that. Next, it's supposed to have transactions. All right, supposed to have its nonce, because we are keeping track of how many times the hash was done. Was generated before we got the right one. The hash of this block and then the hash of the previous block, we'll call that previous block hash. Awesome. Now each of these needs a value, so we'll start from the first one. The index, will give it 1. The timestamp, easy way to do is to use date.now. So that will give us the date of whenever this blockchain was deployed, whenever the blockchain ever started. So yeah, we could also use that to trace it. This would be an empty array because no transaction yet. The nonce will be 0. For the hash, we just put anything there. So for the hash, we just put hash. And for the previous block, we'll give you the value of previous block. All right. I made a mistake here. This is supposed to be colon. So let's remove that and replace it with a colon. And then let's format this document so that it doesn't run through. Good. So it's like this now. So like I said, you could choose to just hard code this and then put this inside the chain like this. You just paste it like this and you are good. But I don't want that. It's making the code a bit rough. So what I would do is, instead of that, I'll just call this function inside of here. So it will be this dot create genesis block. Like I told you, you need this keyword in front of every function that is connected to this particular class. If the function is coming from a different class, it will be that class dot that function. All right, so that's what we have now. If we run this code, you should have the chain with one block, and pending transaction should be empty. So let's save that. Let's move to the first we'll export this file or this class, and then we'll move to the tests in order to test this so that you see that it is working. All right, so to export this, we'll use module.export equal to blockchain. That is equal to the name of the class. So module.export, right? Right, equal to blockchain. All right, that's correct. That's it. Let's save it. Let's make sure we save it. Yeah. So let's move to the tests, and then we'll import. Want to import the blockchain that we just exported. So let's do that. Blockchain equal to require that should be here. Yep, blockchain. Beautiful. So we now have access to the class here. Basically, we have access to this class anywhere in this project. So any file, you could just import this in any file that you create. And then we can now create an instance of this blockchain, and we want to call our blockchain Bitcoin equal to new blockchain. Now this could actually be any coin. We could also call it intro coin. Yeah, intro coin, and we'll make it like this, intro coin, something like that. That still works. For us to see what's happening yet in the program, we just log this to the console. Let's do console.log, and then let's see what's happening in intro coin. All right, so let's go back to our terminal. Now in our terminal, we'll now call node tests. We are testing with our test file, so node tests, and then we hit enter. Beautiful. Now if you look at this, yeah, let me zoom in so that you can see. All right, if you look at this, we have our class, which is blockchain. Inside it we have the chain, and then we have the first block, which is the Genesis block. You recall that we added all these data inside, the index, the timestamp, the transactions, the nonce, the hash, and the previous block. And then we have the pending transaction, which is empty, and that corresponds exactly to what we have here in our blockchain file. All right, that's cool. Something you need to notice: this will not run more than once, just as you have seen here in the terminal. Whatever is in the constructor runs just once, and after that it's not going to run again. So you don't have to be scared if the Genesis block will have to run multiple times or something like that. All right, so that's out of the way. We can now continue building what we have in mind. All right, so the next function we want to build is get last block. We will need this function because we will need access to the previous block. The previous block hash is supposed to be saved in the current block hash. So get last block. What are we doing here? We are just tracing back whatsoever is happening in the last block. We want to get what's happening in the last block, and then once we are able to get the content of the last block, then we can return maybe the previous block by doing that block dot hash. As we continue, you get what I'm saying. So to get this, you just do a return. It's just a one line return this dot chain. If you remember, this is an array, so we need to get the length, that is the number of blocks inside, and then we remove one. When we remove one, we get the actual index, because the arrays we know starts from 0. So we do this dot chain dot length minus 1, and that is it. With this code, we should be able to get the total number of blocks, and then get the last block. Then we'll do whatever we want to do with it. Beautiful. All right, then next we'll now be looking at how to generate a hash. We've already looked at it, so it shouldn't be difficult. So let's say generate hash. All right, it's just exactly what we've done already. So let's just start. We are first of all declare a hash. I'll give it an empty string. We declare a nonce, set it to 0. Then we do the loop, and we are saying while hash dot substring from the first character to the third one, while it is not equal to or equivalent to 3 zeros, keep running. So inside of the while loop, the first thing we want to do is to increment the nonce. We're incrementing it by 1. And then our hash, what do we use to create our hash? We need a string. Now to create it, the best way to do this is to use a string of the details of our block. Now, what we are saying is, in order to create this, if you recall, initially we typed in man, but we want to be very dynamic and make every hash specific to the block. So for us to do that, what we'll do is we create a long string. So the first string will be the previous block hash. Then we'll add the timestamp that we got. We'll add the transaction. Now you recall that the pending transaction is an array, but we need it to be in form of a string. So for us to do that, we stringify it using json.stringify like this, and then pass in whatsoever the pending transaction is, and then finally add the nonce. Awesome. So let's just give a little space here. Now at the end of this hash, we want to ensure that we convert it to a string, so we put it to string, and yes, call the function, and be sure to close that with a semicolon. Just reformat the document so that we have it well formatted, clean and nice like this. Beautiful. Now after the loop is done, what next do we want to do? We want to return two things. We are returning the hash, and we're returning the nonce, and that is all. So whenever we generate this, we want to make sure that we get access to this. So what we've not done is to ensure that we are passing in the details that will be used. So let's get all these details. All right, pending transaction, nonce. No, we don't need to pass in the nonce. Just these three is fine. Copy it, paste it here, separate them with a comma. Make sure they are formatted. All right. Yeah, we don't want to forget. Yes, let's get rid of this. All right. That works. All right. Save that, and then that is it for generate hash. Next we can now let's move forward to creating of transactions. So what makes up our transaction? We just need three things. That is the sender, the recipient, and the amount, and that is all. So create transaction. Create transaction. All right. And we need to pass in the amount, the sender, the recipient. If I'll spell that correctly. All right. Okay, now the easy way to do this is just to push in this transaction into the pending transactions. So for us to do this, we can do this almost in one line. So we just do this dot pending transactions dot push, because this is an array. I'll just make it an object of these three items that I just added: amount, sender, and recipient. And that's it. We've been able to create a transaction. That's all you need. All right, it's just one line. Now to the last block, to the last function, which is going to be the longest function, and of course, the one we'll be waiting for. It's the create block. Yes. It doesn't take in any arguments, by the way. So what we'll do here is first we'll start by let's first of all get our timestamp, because I'll have said let's do this inside of the objects we'll create, but we'll be sharing this. We'll be sending this to create hash or generate hash, and then we'll be storing these details too. So let's start by getting them out. Timestamp date.now. Transactions, it will be equal to this dot pending transactions. Yep. Then previous block hash will be equal to this dot generate hash. Yes. Yeah. This dot generate hash dot hash. Now, what I'm saying here is, if you recall, at the generate hash, at the end we returned these. So in here we'll have the hash and we'll have the none. So we are saying that for the previous block hash, we need to generate the hash, and then we'll get last block. Yeah, I was mixing it up. So remember that we said here you will be able to get the last block in the chain. And so whenever we get the last block in the chain, we can do whatsoever we want to do with it. So here we are getting the last block, and we are using the hash to create the previous block hash. Makes sense? All right. Then the next thing is to generate hash. And for this, we'll call this dot generate hash, and then we'll pass in the details. What are those things we're supposed to pass in? We're supposed to pass in the previous block hash, so we'll have that. We're supposed to pass in the timestamp. We've created that. And we're supposed to pass in the pending transaction. So we assigned it the transactions variable here. You can just format that so that it doesn't get too long. All right, good. Now, after these details have been gotten and returned, next thing we want to do now is to pass in these details into a block. So let's create a new block, const new block. Equal to an object. We are creating an object. And if you recall, when we created the Genesis block, these were the details we use: index, timestamp, transactions, nonce, hash, and previous blocks. Those are the same thing we are using here. So let's begin. Index. So for the index, we just need to get the length of the chain. Whatsoever is the length of the chain, we just add 1. So we just do this dot chain dot length plus 1. So if the chain length was, maybe if there were 2 inside of it, inside of the chain before, we just add 1 and it becomes 3. So this index becomes 3. The timestamp, we already created it, so we don't need to assign it a new value. It already has a value here. If you recall, in objects, if the key and the value are the same, you don't need to specify the key differently and the value differently. Like here we have timestamp equal to timestamp. This will be just unnecessary repetition, so let's keep that. Next, we have transactions. So we already assigned it here, transactions. All right. The nonce. So for this, generate hash got it for us. So generate hash dot nonce. Beautiful. Then the next one is the hash. For these two, generate hash got it for us, dot hash. And the last thing there is the previous block hash, which we got here with the get last block. All right. Oh, okay. Now that this is done, we need to clear the pending transaction, because these transactions that were pending now have a block, and then we'll now add this block to the chain dot push new block. We can return the new block just so that we see what we've added. All right, now that completes everything going on here. And just a recap so that we are all on the same page. Let's begin from the top and run through everything again. The first thing we did here was to create a constructor inside which we put our predefined data. And what are those our predefined data? We need a chain, which is an array. And we need pending transactions, which is also an array. The chain array keeps track of all the blocks, and these blocks keeps track of transactions or group of transactions. The pending transactions keep track of all transactions that has not been assigned a block. So for us to begin this chain, we needed a first block, which is called a Genesis block. This is like a dummy block with dummy details. And like you can see, everything here is basically dummy details, nothing serious. But we needed it to at least start what we are doing from the top. So we created this function. And recall I said you could actually add code this into this place, but I needed my code to be neat, so I had to make it stand different. And then we added it. So that begins the blockchain. Next is the get last block. The get last block gets the last thing or the last block that was added to the chain. So with this, you can get access to the hash of that block, which in the next block will store as the previous block hash. All right. For the generate hash, we passed in a couple of details for the block that we are creating, like the previous block hash, the timestamp, and the pending transactions. And then when we came in here, we started regenerating this hash at this point. We use these details that we got to generate and regenerate this hash until we got to the desired hash, and then we'll add it. Next, we did the create transaction. For a transaction to happen, you need a sender, you need a recipient of certain amount. So that's what we did here. We got the sender's detail, we got the recipient detail, we got the amount that the sender is sending and that the recipient is supposed to receive, and we just add it to the pending transaction just to keep track of it. After that, we now moved to creating the block. Now, for us to create the block, we need to first get the previous block's hash. We need to generate a hash for this particular block that we are creating now. So that's what we did. But for us to be able to generate this hash, we needed to get the timestamp too. So that's why we had to declare it here. Since we are going to use the timestamp here and use the timestamp here, there was no point redoing it. So we just did it one place and reused it multiple places. All right. Then after getting all these details, we came here, created a new object called new block. The first thing is the index, followed by timestamp, transactions, nonce, hash, and the previous block hash. After that, because all these transactions have been able to get a block where they are added to, we cleared the whole transaction so that there will be no duplicates of transaction. Then after clearing that, we added this new block that I just created to the chain, and that is all. We are returning this new block here so that we'll be able to see what we've created. Already we've exported this, so we'll go and test it now. Make sure you save, and then we'll come here. Awesome. Okay, we have already tested what's going on as soon as we start, and we know that as soon as we start we get this. All right. Give me a moment. Okay, so for us to test the create transaction, we will just need to get the create transaction and pass in these three details. So we already have an instance of intro coin. So what do? We just do intro coin dot create transaction, and then first we need an amount. So amount, where we want to send 100 ethers if we have that. For the address, sender's address, you could just put anything there. For the recipient's address, you could just put anything there too. All right. And then, okay, before we add this to the block, let's see what's going on in our code right now. So let's save this, clear what we have here, run the node test again, and beautiful. Notice that the pending transaction is no longer empty, unlike what we had before. The pending transaction now has some data inside, which is this thing that we just added here. Now let's add these transactions to a block. So for us to do that, we need to do, intro coin dot create block like this. Now what do we need to create a block? Everything is already set in place. You don't need to pass in any data, so just call it with an empty braces like this, and then we'll clear this. We'll run the code again. Boom. Now we have an extra block. This is the Genesis block. This is the next block that was just added, and our pending transaction is now empty. Recall that the pending transaction is cleared as soon as a block has been added. Now look at it here. As soon as this block has been created, we empty this, and then we add the new block to the chain. Makes sense? So that's why we have this data like this. If we decide to repeat this down here, so let's make this maybe 660. Let's change this and change this too. All right, and then we'll create the block a second time, so that let's make sure this is clean. All right. Okay, then after this I want to, let's save this first and run this. So notice that initially we had just 2. Let's clear this. We'll run it again. Awesome. Oh, sorry, we didn't save this. Let's save this. Make sure we clear this. Run it again. Now we have index 1, index 2, and index 3. With the first one ran for 490 times, and the second one ran for 8,006 times. If you want to see what's inside the transaction, you will just need to specify the block index, and then it will be revealed. So for example, if you want to check what's in the third index here, you could just do intro coin dot chain and specify 3, then dot transactions. Save. You clear everything here. You run no test again. Made a mistake. Oh, sorry. Supposed to be 2 instead of 3. Arrays starts with 0, not with 1. So my bad. So this is it. This, if you recall, this is the third transaction that was added. It's no longer on its own, it's inside a block, so that's why we had to access the block before we access that transaction. And if you choose to create a new transaction now without creating a block, it's not going to be added to any block. So let's say this is 760. Let's change all this gibberish, just change it like that, and let's bring this back. Intro coin, save. All right, you clear and no tests. Boom. We still have our 3 blocks because we've not created a block, but in our pending transaction we have something, which is what we just created over here, this line. Now, unless a block is mined or created, these transactions will be here. Now, basically, this is how blockchain works. This is just what really goes on behind the scenes that we don't see. It's all about making sure that transactions are safe. like we've seen, we are keeping track of the hash of the current block and the previous hash, that is the hash of the previous block. So with these things are connected together. This means that you cannot just come and put in a transaction from nowhere to break in what's happening there. It's too secured for somebody to just break in. And so this is why people have continued to adopt blockchain. And I'm sure that you enjoy learning about blockchain and of the endless possibility as we continue. So this is it for this video. I will see you in the next video where we'll be talking about Solidity. I'll be teaching you how to use Solidity to build smart contracts. And by the end, you should be able to build basic smart contracts. See you.